Function to determine if two numbers are nearly equal when rounded to n significant decimal digits. I have been asked to test a library provided by a third party. The library is known to be accurate to n significant figures. Any less significant errors can safely be ignored. I want to write a function to help me compare the results. The purpose of this function is to determine if two floating point numbers, a and b, are approximately equal. The function will return true if a equals b, exact match, or if a and b have the same value when rounded to sig fig significant figures when written in decimal. Can anybody suggest a good implementation? I've written a mini unit test. Unless you can see a bug in my tests, then a good implementation should pass the following. Additional notes. Values a and b might be of type int, float or number py.float64. Values a and b will always be of the same type. It's vital that conversion does not introduce additional error into the function. Let's keep this numerical, so functions that convert to strings or use non-mathematical tricks are not ideal. This program will be audited by somebody who is a mathematician who will want to be able to prove that the function does what it is supposed to do. Speed. I've got to compare a lot of numbers, so the faster the better. I've got number py, SIPy, and the standard library. Anything else will be hard for me to get, especially for such a small part of the project.
As of Python 3.5, the standard way to do this, using the standard library, is with the math.isClose function. It has the following signature. An example of usage with absolute error tolerance. If you want it with precision of n decimal places, simply replace the last line with
There is a function assert_approx_equal in numpy.testing, source here, which may be a good starting point.
Here's a take.
I believe your question is not defined well enough, and the unit tests you present prove it. If by round to n sig fig decimal places you mean n decimal places to the right of the decimal point, then the test assert nearly equal, 1 times 10 to the power of 9, 1 times 10 to the power of 9 plus 1, 5, should fail, because even when you round 1,100,000,001 to 0.00001 accuracy, they are still different. And if by round to n sig fig decimal places you mean the n most significant digits, regardless of the decimal point, then the test assert nearly equal, minus 1 times 10 to the power of -9, 1 times 10 to the power of -9, 5, should fail, because 0.000000001 and minus 0.000000001 are totally different when viewed this way. If you meant the first definition, then the first answer on this page, by triptych, is good. If you meant the second definition, please say it, I promise to think about it, smiley face.
There are already plenty of great answers, but here's the thing.
If you want to stop the channel, please send in a like and subscribe.